Hi, this is Mr. Rankin making a quick review of some questions that you're likely to see on the Math Fast. First, talking about association, also known as correlations. If when you read your graph from left to right, if it is going up from left to right, we call that a positive association or correlation. As you read it from left to right, if it is going down, we call that a negative association or correlation. If there's no discernible pattern, we call that no association or correlation. If we have, if you have a pattern that looks like a straight line or is a straight line, that correlation or association is linear, because remember, linear means a straight line. If you have a correlation or association that is not forming a straight line, more or less forming a curved line, we call that a nonlinear association. If your points are close together, then we call that association or correlation as being strong. Okay, so here are examples of strong positive and strong negative correlations or associations. If your points are more spread out or more dispersed, we call that correlation or association as being weak. Okay. Another concept we talked about so far in the year is numbers of solution, particularly looking at a graph. If you have two lines and they are intersecting, that point of intersection shows that there is one solution. And even more to the point, that point of intersection is the solution to basically your system. So in this example, our solution would be our ordered pair 2, 4. Okay, so if you see this on the fast, the point of intersection is your solution, and that is one solution, which is a point of intersection. If you have two lines that are directly on top of each other, we call that infinite number of solutions or infinitely many solutions. Okay, so with this red line, there's actually two lines directly on top of it. Okay, or on top of each other. So we call that infinitely many solutions. If you have two lines that are parallel, which means they do not touch, they never touch, there is no solution to the equation. And then this is what it looks like as in terms of um, the equation. If the numbers, if it has one solution, it is it'll be have one point. If both sides of your equation are equal, then it is infinitely many solutions. And if one side is not equal to the other side, actually is really one number or constant is not equal to the other, then it is no solution, because as you can see here, that would be a contradiction. If you recall, when we looked at triangles, every triangle, regardless of its shape, regardless of its size, has 180 degrees inside of it. Okay, all the interior angles are 180 degrees. Therefore, if you know the measure of two triangles, just as an example, let's say this triangle is 60 degrees and the other triangle is 70 degrees, we can add those two together and find out the measure of the missing angle. And if you recall, for exterior angles, okay, let's say we have an angle out here, we'll call this angle D. Please be mindful that the two opposite interior angles, 60 and 70, would be equal to this exterior angle. Sorry, that was a straight mark. So this should be 130 degrees on that exterior angle of D. If we were to take our triangle, which is again 180 degrees, and we were to unfold it into a straight line, also known as a straight angle, this straight angle, if you recall, or semicircle, is also 180 degrees. Okay, when two or more angles add up to 180 degrees, we call them supplementary angles. Okay, as you can see in that example, if two or more angles add up to 90 degrees, forming like a right angle, those are called complementary angles. And lastly, if two lines intersect and form angles that are basically mirror reflections of each other, they are vertical angles. With vertical angles, it is important to remember they are not equal to 180. They are not necessarily equal to 90. They are equal to each other. So looking at this example, let's suppose the angle 1 is 100 degrees. Okay. That means angle 3 down here is also 100 degrees. Okay, because they're mirror reflections of each other. Okay, and if we were to make a straight angle or look at angle 1 and 4, which are adjacent to each other, if these two angles are adjacent as well as supplementary angles, that means together they have to add up to 180 degrees. Okay, so if angle 1 is 100 degrees, that means angle 4 has to be 80 degrees. Okay, and therefore angle 2 is also 80 degrees because angles 2 and 4 are vertical angles of each other. So just be mindful of that, that they need to be equal to each other, the vertical angles, not to 80, 180, not to 90 degrees. Lastly, we talked about functions. Remember, functions are a rule in which one input can only have an input can only have one output. Okay, so it's fine that 2 goes to negative 1. It is fine that 4 goes to 0 and 5 goes to 4. It would even be fine if 2. Sorry, let me just erase that. It would even be fine if 2. Um, write this again. Sorry, if 2, 4, and 5 all went to say 0. That is still fine. Okay, as long as an input only has one output, that is fine. But if you look at here in the middle, when we have this input of negative 4, that has two different outputs. And that is the problem. That is where it is no longer a function. As you can see, it's not a function when an input has two outputs. And lastly, when you're looking at that in terms of a graph, we have to look at what we call the vertical line test. Okay, in the vertical line test, it's like your function is scanning left to right. And as it scans to left to right, at any point, if it touches the line, your scan touches the line twice or touches two dots, it has failed the vertical line test. So it's not a function. So I circled those 2 points because they're there, but there's multiple points in which your line is failing the vertical line test. Okay, as you can see with example B, it actually passes the vertical line test because even though it looks like maybe it's going to be touching more than once, it only touches once. On example C, as you can see, it fails multiple times on touching the top and the bottom of the vertical line test. Okay, and same thing on example D, it touches multiple times as well. So these are just some examples of questions you're likely to see on the FAST test. So good luck on your review. Thank you.